The most useful thing that the periodic table gives us is the oxidation state. What charge is an element going to become? So the main point here is when you see an element like chlorine like this, that you also see the Bohr model Lewis dot structure and also the electron configuration in your head. So to draw the Bohr model for now helps us visualize what ion an element is going to become. And remember, all we use is the group number at the top of the periodic table to tell us how many valence electrons. Chlorine is in group 17. Any number, group number above 10, we only pay attention to the ones number. And since chlorine has 7 valence electrons, it's very close to 8. And this is all based on the octet rule, having 8 valence electrons in your outer shell. So chlorine becomes a -1 here. And then here we also draw in the neutral, chlorine, Lewis dot structure, and then also the ion Lewis dot structure. As you can see, the Lewis dot structure is just a simplified version of the Bohr model with just our valence electrons drawn and nothing else except the atomic symbol. Okay, here we have calcium, and since it's easier for us to lose 2 valence electrons to have 8 in our outside shell. We are going to do that. We're not going to gain 6 to have 8. And so it's not going to become a -6. It's going to become a +2. So what you want to be able to see in your head is that the Lewis dot structures are just simplified versions of the Bohr model. We have 2 valence electrons, and to show that we lost them over here, we don't draw any. That doesn't mean we don't have 8 valence electrons. We still have 8 valence electrons underneath, but to show that we lost them in the Lewis dot structure, we don't draw them. Okay, now we have silicon, and what we see here is we have 4 valence electrons, so it means we're halfway between 0 and 8, so we can lose or gain electrons. Same amount of energy involved here. Here I gain 4 electrons. I show that I gained them in my Lewis dot structure and also write the charge. Over here I lost my valence electrons. I still have 8 underneath, but to show that I lost them, I don't draw any dots to show the difference there. Germanium, same thing as silicon. It is in group 14. It has 4 valence electrons. The group number on the periodic table tells us that. We don't have to draw the Bohr model. All we need is the group number, but it helps. And so for nature, it's just as easy to gain 4 as it is to lose 4. Here I gained 4. I show that I gained it by drawing my extra dots and my charge. And then over here, to show that I lost my valence electrons, I draw no dots. Oxidation state.